Okay, this will be the last video shot for today. I've been playing around all afternoon with various inductors, toroidal wound inductors like this, smaller ones like this, some prefabbed inductors for RF use, 1 millihenry. And I really haven't seen a whole lot here. I want to show you real quickly. The scope is on the 2 volt per division scale, and with the input grounded, the output, or the base reference, is 0 volts right here. When I turn it to DC, you'll see it jumps almost 2 volts. I'm going to say right now it's about 1.5 volts. When I turn the pulse width modulator on, I'm pulsing it up to about 14 volts. The settling voltage is about 2 volts. So the cell has risen to about 2 volts as the settling voltage, with the pulse width modulation going into it. But it hasn't really responded. What I'm looking for when I sweep through the resonant ranges is that this voltage, the settling voltage, goes up at the point of resonance, and I have not found anything even similar to that right now. I'm only driving it with 14 volts. This is pure distilled water, no electrolyte in it, and I was I don't know what I was expecting to see, but I guess the next experiment I will try will be with a normalized concentration of electrolyte, and see what kind of effect I can get out of the cell from that. It's been an interesting development here at Sub-Zero Labs. Remember that blue capacitor that used to be on that printed circuit board? Well, I was in the middle of performing some tests on the spiral cell in potassium hydroxide, and I was cranking along real nice, seeing some interesting transients on the oscilloscope, and all of a sudden I heard a big pow. So naturally I thought I had cooked the power MOSFET, because I immediately lost my waveform. And I opened it up and discovered this. I should have recognized the smell of the electrolytic capacitor, but it sprayed paper and plastic all around the inside of this. It really was quite a very loud explosion. It sounded like a firecracker going off. Here's the undercover of that. So I'm going to have to clean all that out and put another capacitor on there. I think what I'll also do is I'll put maybe a 10 or 20 ohm resistor in series with the DC power going to the electronics control board. That way it'll buffer the current of any of that transient voltage trying to get back into the controller board. I'll be back later. Okay, here's the repaired printed circuit board. You'll notice now, next to the voltage regulator, there is a 1 watt resistor standing up. That 1 watt resistor is 18 ohms. It's what I had laying around. And there's a new 10 microfarad filter cap, 50 volt, identical to the last one. But what should happen now is that 18 ohm resistor is in series with the DC power coming in before the filter cap. So any transient energy that is trying to enter the printed circuit board should be buffered by that resistor. The value is low enough not to present any voltage drop to the LM324, which does not draw a great deal of current at all. So hopefully this will prevent any future explosions at Sub-Zero Labs. Of course, once again, the bulletproof IRF 064 withstood the blast and came through with shining colors. So I'm very pleased about that, and not burning up any MOSFETs. Not today, anyway.